In this video, we're going to touch on some of the other data storage types: matrices, lists, and data frames. A matrix is a two-dimensional array of values. It's very similar to a vector, except instead of just one list of numbers, I actually have them stored in a two-dimensional array. The function to create a matrix is, as you would expect, named matrix. And how do you create it? You actually pass the function matrix, a vector. That's in the data function. Data equals, and you pass the vector. Now you might say, how can I pass a vector and make it look like a matrix? Well, what it does is the matrix function takes in that vector, and you tell it how many rows, and how many columns, and col, you want. And what it does is it then puts it into a matrix in a fashion that you would like. Now, you might say, well, how does it do it? Does it fill it row by row by row, or does it fill it column by column by column? Well, by default, there's that option that says by row. And by row is by default equal to false, which means that in general, if I type in, let's say I have the numbers 1, 2, 3, 4, and I type it in and say I want to fill this in with 2 rows and 2 columns, and I want to do it by row equals false, I'm going to enter column-wise, 1, 2, 3, 4. Now, if I say by row equals true, I will enter it in a row-wise, 1, 2, 3, 4. Now, as I go through that, that's really one of those things that you practice, and there's lots of examples I provided again. I really recommend you take some time to look at them. I don't know how much we're going to use the matrices or the matrix in this class. There may be some times when we learn regression, I'll kind of bring that up. Regression, I think, will be the most common area we'll use it. But in other classes going forward, I think this will be a very useful function to have and just to understand what a matrix is. How do you index? And I say I want to pull out a specific element from that matrix. It's very similar to how you dealt with vectors. You use the square brackets, but this time you have to give it a row and column index to say I want the ith row and the jth column. So if I want the ith row and jth column of the matrix X, we'll do X square bracket I comma j. Now, one of the nice features with R is sometimes you say I want the entire ith row. I don't care what column it is, just give me the whole row. Well, if you put I want X square bracket I comma and then leave the column entry blank, it assumes you mean give me all the rest. Give me the whole, the entire row, every single column. And similarly, if you want every single row inside a column, you can put comma and the column index. Practice with those with the R Markdown file and the examples just to see how that indexing works. That will be something that will be very useful when we're kind of looking at data, because when we talk about data frames at the end of this video, a lot of the indexing is exactly the same. And that's something we are going to use quite a bit in this class. Note, we do use square brackets here, just like we did with vectors. Square brackets are required. There's a bunch of matrix functions I have listed here, again, for your own personal use. Some of them are a little high-level linear algebra functions that you may never need. Maybe in other classes you will need them. We won't use a ton of them in here, but I will draw your attention to a few for this particular class. The matrix multiplication we will certainly use at some point. Number of rows, number of columns, or there's a dim function that we can use for that. That could be used. The solve function is quite common because that's how you invert a matrix. You don't raise it to the -1 power. You actually use the function solve. We'll see that later on in the class, and I'm sure you'll see it in future courses. And transpose, switching the rows and columns. Lists are another data storage type. They're vectors, but they have a little bit more flexibility. They can contain different types of data. So remember, vectors, if you have a character and a number, they cannot be stored in the same vector. Lists don't have that restriction. So I might say I want to contain a bunch of information about a person, their name, their social security number, their height, their references, their transcripts, whatever. Some of these, name, list of references, well, list of references, boy, that's another list. Their transcript, that kind of, the name is a character, Social Security number probably would be denoted as a character or a factor. Height, number, list of references, that's another list. But a list can contain other lists. How do you create lists? Well, it's pretty intuitive. There's the function called list. Whatever you want the name of element 1 to be called, so perhaps this is the name. I say name equals, and then I have the person's name. Social Security, SSN equals, put the Social Security number. List of references, or I could say references equal another list. That's how I create it. And if I want to access elements in a list, I do it a little differently. It's not the same as a vector. I will use double square brackets to pull out an element of a list. For lists, we can also do some things known as double indexing. Lists can contain other lists as elements or vectors as elements as well. If I want to access an element of a list, I still use that double bracketing. But what if I want to access an element that's an element in the list, kind of a double layer? So the example I have here is, what if I have a vector that is the first element of my list? That first element of my list is an entire vector. And I specifically want the third element of that list. Well, I start from the most general, saying, look at the big list and say, give me the first element of the list, the whole vector. So I want to use the double brackets to get the first element of the list. Then I say, okay, well, this is going to be a vector. Give me the third element of that vector. Well, to access an element of a vector, I use the single square bracket. Again, plenty of examples for you to play around with online. Data frames are ones that we're going to be using quite a bit in this class, and you'll be using them throughout your career here at Ohio State. Usually this is what we think of as a data set in data science. The columns of a data frame are the variables, and the rows are the observations. We use the $ operator to access a specific variable. So suppose I want to access, remember I talked about a frame that has everybody in this class, that has their name, their social security, their email address, their height, their GPA. If I want to access, hey, give me just the heights of everyone in the class, I would say data frame, $ height would access the height column. I can do indexing similar to a matrix because if you think about it, a data frame is two-dimensional. Or I can say, well, let's pull out just the height column and give me the third element. Well, the height column is a vector, so I would index similar to a vector. We can also use the name of the variable to index as well. If you want to know the list of the variables that are in the data frame, I can use the names function. Here's an example that I built from scratch, but I don't know if it's one of those that there's lots of examples out there. Usually you won't have to create the data frame. It's usually already in a nice form. But if you notice, I created a list of names, all my people in the class. Student IDs, these are all vectors. Majors, notice I've also used that rep to say, look, the first two are marketing, the second two are finance, and the last one's stats. And I have the list of genders where I've actually listed all the genders out. Some of these values are characters. The student IDs are technically a number. If I want to combine them all into a data frame, I use the function data.frame to say, hey, I want the first name is the name vector. I'm labeling it as first name. Student ID is the student ID vector, and so forth. This forms my data frame, and now I can say, hey, of my freshmen here, I would like to find out the third student ID. The $ says access the student ID column, which is just the same as this vector up here, and then it picks the third element. For freshmen here, notice I've done it as a matrix indexing. So I can say, give me columns 2 through 3. That would be student ID and major. And then I want the second student, which would be the student ID for the second student would be 43678, and the major for the second student would be marketing. Once again, practice makes perfect. Try some examples out, play around with it. That's really how you learn coding. I can also create new variables quite simply in data frames. I simply store a new vector, or it would have to be a vector here, a new vector into a new column. So if I want to create a new column called GPA, that doesn't exist. But if I do freshman $GPA, I'm creating a column, and in that column I'm going to store this vector. Now if you notice, if I go ahead and type in freshman to the computer after I've done this, it will have a new column in it called GPA that will have these numbers associated. You don't need to create a new column before you store it. You can create it as you're storing the values in there.